Welcome. In this lecture, we're going to talk about basic set theory. Well, we all know, I hope, that a set is just a collection of elements. Each element of the set we either call an element or a member of the set. And here are some examples of sets. The set of integers, and we frequently use this fancy Z to represent the set of integers. The set of integers, it's all positive and negative whole numbers, includes 0. The set of uppercase letters, that would be capital A, capital B, all the way to Z. We could write that like this. The dot, 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 obviously the ellipsis just means continue the set. So this contains 26 elements. The set of real roots of this equation. Well, that means that x squared is equal to -1. In real numbers, you can't square a number and get a negative. So this is the empty set, or another way of writing it is that, the empty set. The set with no elements. The set of roots of this. Notice the only thing missing was the word real. Now if we have x squared equals -1, we do have a solution in the complex world. X equals plus or minus I. And if you haven't had any complex analysis and don't know what complex numbers are, that's perfectly fine. We will probably never see that in this course. The set consisting of 5, 6, and 7. And the other way to write that is just put 5, 6, and 7 in a roster notation and put squiggly brackets around them, just like this. The next one is a set of integers strictly in between 4 and 8. That means the integers 5, 6, and 7. Well, we saw that above. So these two describe exactly the same set. Just like that. Different ways of stating them or defining them. And then what does it mean for a set A to be equal to a set B? Well, given sets A and B, if every element of A also belongs to B and every element of B also belongs to A, then the sets are equal to each other. In particular, that means they have to have, if they're finite sets, they have to have exactly the same number of elements. And those elements have to be precisely the same. And in case you don't remember, in a set, you never repeat elements, and order doesn't matter. So the set with 1, 2, and 3 in it is the same as a set with 3, 2, and 1 in it. Those would be two equal sets. And just a symbol that we use, if y happens to be an element of the set A, then we say y is an element of A. That's what this symbol means. And if it's not the case that y is in A, then we say y is an element of A, but we put the slash through the is an element of. This means y is not an element of A.